CK. The last few times I've built a Eurorck unit, I've said, and I can't do this because I don't have CV out here in the workshop. Oh, I can't do that, I got to get a CV input. So finally, I bought another kit from Befaco. This is their MIDI Thing version 1, and it's MIDI to CV. So I can finally have a little CV output here that I can feed into the modules that I'm putting together and testing. So, looks like a fun kit. We'll take a look at it. Hope you enjoy it. So, the fun part. Let's see what's in the bag. Befaco MIDI Thing, or Befaco MIDI Thing version 1, full DIY kit, out of Barcelona, Spain. Support at befaco.org, and they have a good web page also. So let's take a look inside and see what we got. Got a little sticker. Always good to have stickers. Gonna go put it up on my wall of stickers right now. A little blue tape. Put it in the corner, stick it on the door. More stickers are good. Let's see what we've got inside. It's got knurlies inside. Knurlies are panel mount screws. If you're not familiar with them, I'll show them to you when we break them out. And this is a sticker too. So I've got 2 new stickers for my wall of stickers. It's actually not a wall, it's the door to one of my cabinets. Let's see what the paperwork says, and it feels like there's a circuit board and panel in here too. Yeah. Ooh! 2 circuit boards. It's a 2-layer kit. That's interesting. So that'll make it more of a challenge, mainly because then you have to screw them together. So let's open this up. And we've got, I'm going to take the circuit board out first, I think. Actually, I'm going to have to cut this way also. So there's the front panel itself. MIDI Thing. Learn, I don't know what that is. Push to release mode, push for 5 seconds, so there's obviously push buttons in there. Then 1, 2, 3, 4 pairs of CV outs, and then clock and gates. I'm not sure what these are going to be, and I'm going to assume this big place is for the antiquated MIDI connector. And here's the board. And obviously to me, we're going to have to split it here and take off these side tabs too, I believe. And let me take a look at the board and see if there's anything particularly interesting. Board looks pretty good. There's one surface mount component already on. I'm not sure the holes are plated all the way through. I know these are not, but these may be. Actually, this one is clearly plated all the way through, which means all the smaller ones will be too, I'm going to assume. So that's good. Always quality. So as we can see here now on the board more directly, the pairs are, there's CV A, B, C, and D, and gate A, B, C, and D. And then clock signal and STSP. I'm not sure what that is. I'll figure that out later. And the MIDI connector of course, there. So let's look inside the paperwork itself. And you've got, welcome to this. Oh, that's interesting. Some steps are not obvious. So even if you're an experienced DIYer, please take time to read the steps thoroughly before starting, which is always a good idea. So another picture of the PCB. So there's not a lot of text here. So yeah, while he says that you should read all the instructions to see if there's anything unusual, there's nothing unusual in this particularly. So now let's look at the parts. A lot of parts. Going to be longer than the last build. Here's all our jacks for CV and gate. This bag has resistors, tantalum caps, a few electrolytic caps, some diodes. So basically all the passive components, and it's labeled bag A. A bag with some more resistors, some LEDs, oddly shaped LEDs. I mean, not odd, just not standard. Let me pull one out. As you may be able to see here, the top isn't rounded. It's got a little protrusion that I'm sure goes exactly through the hole here. Yeah. Oops. It goes exactly through the hole there, so you get kind of a smaller LED light. That's a stylistic thing. And we've got the ubiquitous Eurorck ribbon cable. This time, fortunately, he's got the full-size connector on one end and the shortened connector that he's going to use on his board on the other end. So I don't have to use my power connector, power source where I've clipped off 6 of the pins, because not everybody is this thoughtful about including the right type cable. And here we've got 1, 2, 3, 4, 5 sockets and 1, 2, 3, 4, 5 ICs, and then here are the knurlies, and then there's this, which, oh, look at that. So, I don't know, it's labeled Befaco, and it's knurled here, as you can see, but what you may not be able to see is it's got little tabs here, so it is A, and I'm trying to be dramatic about the reveal, for even though the only people who haven't figured it out yet are not actually looking at the video right now. So it's a panel screw wrench, panel nut wrench. So it fits in there, and when you're mounting your sockets or switches, you can tighten up using that. That's real nice. It's nice that they threw that in there. It's a good solid piece too. It's not just it's not lightweight, it's heavy enough to give you a good feel. So that's nice. That'll go earn a place on the workbench. So the first thing I'm going to do is separate the PCBs from each other. And because I'm a little compulsive about things like this, I have a little piece of sandpaper and I'm gonna sand this off a little bit. The main PCB, as he emphasizes, the small one. And we open bag A. I almost cheated y'all out of the most exciting part of my video. So let me get another parts tray out. And we'll dump bag A into that. And we're going to start with 4 1K resistors. I'm going to be putting on a bunch of resistors, so I'm going to go ahead and speed the camera up for this next section. And of course, when you see me reaching over like this, what I'm doing is before, when I speed the camera up to do just soldering with no commentary, I turn on my iPad, I turn on the WQXR app. That's WQXR out of New York, available through the app worldwide for the best classical music. I'm going to pause soldering for a second and make some commentary here. This board is really tightly packed. For a through-hole board, I'm not sure this is a great thing. Like right now, I'm trying to find R14. So here we have R11. Here's R12, I think. Here's R13. Then we've got R16 here. And I think this indication on the board saying R15 goes here. So this could be R14 by process of elimination. But the silk screening is really, it's off the side of the board, so you can't see it that well, and the letters are incomplete, and the shape is not perfect. I'm going to actually look at their website again. A circuit board picture. Oh, there we are. The instructions do have a circuit board picture, so that's okay. So that is, in fact, where R14 goes. But this board is really packed. Be careful when you're assembling this to make sure that you're getting it in the right spot. Again, the instructions do contain a picture so you can find the right spots, but so don't rely completely on the board. Now back to soldering. Alright, that's all the resistors on the main PCB. Now we've got 2 diodes. Oops, I'm sorry, let me clip off the leads here. Now one thing, or again, the other aspect of this board being so densely populated is just be careful when you're doing this one about bridging. Like say this spot right in here, that's a bunch of connections really close to each other, and it'd be easy to bridge them if you're not paying attention. Now, I do want to point one other thing out about that. Again, as I often comment, boards that have plating all the way through the holes are very good because they make it really hard to get a bad solder joint. You're rarely going to get a cold solder joint if you've got that much metal on the board to work with. But one thing that they do have a side effect of, it also means the solder flows through the board to the other side, to the silkscreen side. So on a PCB that isn't plated through the holes, the fiberglass or whatever material it is, fiberboard, is going to resist the solder flowing through. Since these are plated holes, not only do you get a better connection, but you also get solder flow through the board. So it is possible to bridge contacts on this side of the board also. So if you ever are trying to look for a short or something that's not working quite right, and all the solder joints look fine on the back, you may want to look on the front and see if the solder has penetrated all the way through and bridged leads on that side. Just something to consider on these fancy boards. Again, I like them quite a bit, but that's one aspect that can cause minor problems if you're not careful. So we've got two diodes, we've got three diodes altogether. Now this polarity marking on the board is a little unclear. I believe it goes this way. That seems to match with what's on the drawing, but it doesn't have a clear positive indication, or even the diode symbol. One thing you also may notice, another thing you also may notice as you look down on this board, that the traces are very curvy. They're not as angular as most circuit boards I've looked at in my lifetime. I'm going to zoom in a little bit more so you may have a better look at that. If you can see, say here, this curves around, it's got a curve in the middle. This trace has a curve and a little bump and a little hump. This one is kind of bent down and wiggles around. It almost looks like it's replicating actual wire, which is kind of unusual. I'm not sure what the point of that is, but it's interesting. So the diodes are soldered. Now the next interesting thing here is, and let me see if I can find them, is we have some ferrite cylinders, ferrite cores, that we're going to take some resistor wire, a resistor lead wire, feed through them and put them on the board. And this is a brown black inductor, and I have no idea what the inductor color codes are. This calls it 22 microhenry or picohenry or micron henry. Again, I'm never very good at henries. I've said that before. You might not have heard it before, but I've said it before. And then the timing crystal, and what is this? I can't read it. 16 megahertz? Yeah, 16 megahertz. And I mean, it's somewhat obvious where that goes, but since I've been double checking everything else, I'm going to double check that. Okay, now 8 capacitors, 100 nanofarad 104s, 8 of them. Okay, now we put all the sockets on the board. Again, five ICs, 5 sockets. And again, the best way to deal with IC socket soldering, first make sure the notch is in the right place, is put it on the board. Then grab a handy dandy pair of locking tweezers, slide it down like so. Then the IC socket is firmly against the circuit board, and just tack one leg. I'll tack a leg down at this end. I'm going to do one in the middle also, just 'cause. And you can take the tweezers off and you're ready to go. And then you can rip through all the other pins. And I'll be doing that for each socket, of course. Okay, now we got to figure out which IC goes where. So IC1 there are two LF412s. So we'll grab those two. And they go in IC1 and IC2. Let's tuck the legs in a little bit, like we always do. And find IC1, which is at the top of the board, yonder. Legs are all lined up. Nope, this one's a little pushed in a little too far. So we'll pull it back a little bit. There we go. Now it'll go in smooth. Perfect. Okay, now while they're all seated, I'm going to bring up the data sheet on them so we can see what they are. And something just fell down. That's always good. It was my rechargeable battery holder. I don't really care. So the main one is the Amtel 35473D. It's an 8-bit microprocessor, advanced RISC architecture. Ooh, RISC, it's so advanced. Sorry, it's 2021. It's not advanced anymore. 32K of flash. That's not very big. It's got some counters and so on. So that's the main processor. Now let's get the next ones. LF412s. See what those are. 2 op amps. Then we've got 6N138. Oh, Darlington optocouplers. Oh, and one more chip, which would be this 8-pin. This is a Texas Instrument part. CD 450 for Baker Echo. Oh, it's voltage level. It's a shifter. Hex voltage shifter. Taking from logic level to different logic levels, high states. So those are the chips that power this little beast. And they're all socketed. Next we're going to put the voltage regulator in. And here we are. This is a 78L05. Now I gotta find where it goes. Obviously we're looking for 3 pins in a line. There it is, okay. And as always, for some reason or other, transistors, voltage regulators, any 3-pin component is my least favorite to solder. I don't really know why. Just always has been that way since I was a lad. Now 3 10 microfarad electrolytics. You can make sure the cap leads don't interfere with the ferrite core leads because they're really close together. Double checking everything on the back so far to make sure nothing appears to be shorted. So far so good. Now we're going to put the pin header. Now some of them go on the front, some of them go on the back. As he says, place and solder the male pin headers over silk screen at JP1, JP2, and ICSP. Caution, the 2x3 pin ICSP is soldered on the reverse side of the PCB. And JP102 is an expansion port. There's nothing that goes there, but let's see. So ICSP is right here. Now here's the most fun thing to solder is pin headers, because I always use my pinky finger to stabilize them. And of course sometimes I put my pinky finger on the pin I'm actually soldering. And that's always fun to watch me burn myself again for the millionth time. I didn't do it that time. Make sure I got that. It's pretty perpendicular. Perpendicular enough for... Yeah, this is where, in this day and age when our documentation and build materials are all electronic, this is where it's really incumbent on people who make kits to actually have a photograph of both sides of every board or every component set you have somewhere in your instructions. It just puts people's mind at ease and they have a quick reference to what's going on and whether they've got things right or not. So JP1 and JP2, that's JP1, where's JP2? There's JP2. And ow, yeah, I did just burn my pinky. I knew it. I don't know if you just caught that. I'll talk about it here in a second. But it's, again, a commentary reinforces what I was saying about the pitch of these components, the closeness of the solder holes. As I was soldering this pin, this third pin on the regulator, it's actually one of the resistors, melted too because I was so close to it. Again, I really think this board could use a little more breathing space. I know Eurorack's all about cramming as much as you can in the tiniest space you can. Okay, now we're going to finish up bag A with the power connector, with the standard Eurorck power connector. And if you look, he's got it marked here and on the other side with where the red stripe, which is the 12 volt negative, goes. So we'll just double check that the keying is right, because it doesn't hurt to double check, and yep, that's going to be correct. Now, don't spare the solder on the power connector because it's the only thing that's keeping the power connector on the board when you're plugging and unplugging it. You may not plug and unplug it a lot. You set up a rack and it's going to sit relatively static for a long time, hopefully. But then again, another point of Eurorck is to be able to rapidly reconfigure as your ideas and needs change. So just make sure that all these pins have a good amount of solder so they can take the mechanical forces of the cable being pulled in and out of them throughout their lifetime. Okay, so that's the main board all done. This connector position is for expansion. It's not used at this point. And as we like to do, we're just double checking that there are no sockets or holes or positions unfilled. And that looks like a good board. Next, we're going to do the control board, which contains all the sockets and the MIDI socket and LEDs and so forth. So we're diving into bag B. And of course it's got a bunch of little dopey resistors. So let's just take a quick look. Once over the parts, MIDI connector, switch, standoff spacer, the other side of the connectors we put on before, bunch of the LEDs as I showed before with the little taper at the end, bunch of dopey resistors, screw, I'm not sure what that goes to, but we'll see when we get to it. So first thing we're going to do is put all the resistors on and That means we go back into fast motion mode. Okay, now the female pin headers. We want them to go on this side because they're gonna mate with their male friends like so when we stack the boards later. Okay, so that's all right. Now we're going to put the spacer in. This is the spacer, I guess. Secure it onto the control PCB. Here. Oops, gosh, dropped it on the floor. And this is the spacer. I guess. Actually, I don't know what the heck he's talking about here. Oh, is he talking about that spacer? Oh, I see what he's saying. That's not the spacer. He's talking about the standoff here. So, we're going to want to put the standoff like that through there, because then when things are mated, it provides additional support, so the boards aren't being held together, aren't being held together simply by the pin connectors and sockets. That will have an actual mechanical connection that we can tighten, and we can be pretty sure it won't loosen up that much. Man, that nut is awful close to those switches. See right here, I'm going to have to rotate this just to be sure. I'm going to rotate this nut so that the flats are in line with the sides of the switches, or else I think that the hex points would have interfered. So, that's done. We'll proceed to mount the jacks, MIDI connector, switch, and LEDs. This part of the assembly is critical. Yeah, the problem, anytime you're doing this, whether you're doing it on a guitar amp, a home stereo, a musical instrument, just making sure your front panel lines up with the components is always can be the most frustrating thing. So I agree with the author. Be really careful when you're doing that, or doing this step, or else you'll just be frustrated, and being frustrated is not fun. So again, his main guidance is put all the components in, don't solder anything until you put the front panel on. Now we'll do all the mini jacks. And of course they come with these really attractive, and I mean that sincerely, I like these quite a bit, burgundy anodized lock or mounting nuts. I like that quite a bit. That shows a bit of style that I appreciate. And one thing you'll notice if you get this kit, and you might not notice immediately, he alternates the legs. So wide leg, wide leg, wide leg, wide leg. Don't try and put them all in the same way. It obviously doesn't matter electrically. It's just for you putting it together. Don't get frustrated. Now it will be a pain in the butt. I'm seeing it already. These LEDs because of the way they're designed. I showed you earlier they have a taper. They have to go through these tiny holes here, and as you can see, they're in the middle of these switches. So, I mean of these jacks. So it's going to take some messing about to get them to go in right. And then to have them stay in until you solder them, I will probably mess it up at least once. Okay, now we're going to line up all the Sorry for the jump. I didn't realize my cameras had timed out. They time out after 29 minutes of videoing. Maybe someday I'll get a real video camera and won't have to worry about that. So what we're going to do is slightly different than what he recommends, and that's because, and it's primarily based on, as I'm looking at these components, I'm not getting any slop here, so that's good. So what I'm going to do is I'm going to put one panel nut here on this socket, tighten that down, and one on the socket way up here, and tighten that down, all while keeping these pressed firmly together so nothing falls out. And take a little piece of solder and just kind of the same way you do with an IC socket, I'm going to tack this. I'm going to tack one leg of this socket in place, and then do the same thing at the other end on the one I have to remember which one and you can't tell, but I'm keeping a large amount of pressure on these. Okay, good. Now they're both tacked in place, so the board's not, the front panel and the board aren't going to separate. So I can go ahead and put all the rest of the panel nuts on now. And now we get to use the handy dandy panel nut driver that they included. I'm not tightening these a lot, just snugging them down. Okay, they're all happy. Now we'll put the push button nut on, and you notice I didn't tack the push button nut, the push button to the circuit board. I didn't tack solder that in, and the reason why is because it's a different height, it's shorter than the jack, so as you tighten it down to the panel, it draws up from the circuit board. So if I had soldered it ahead of time, there'd be too much tension on it, even to the point of potentially putting a little stress, bending stress on the board of the front panel, and we don't want that. It's interesting that he puts a lock nut, a lock washer behind this push button. I guess it is used quite a bit. Okay, now let's see about these LEDs. Oh, they drop in very well. No problems at all. I don't have to fight with these at all. Good. Bent the legs on that one. That's my own fault. But they're all dropping in very nicely. Again, good CAD drawings, or good design on the mechanical side on this, which is really nice. Now I'm gonna go ahead and solder. Oh, that one does seem loose. Okay, I'm gonna go ahead and solder all these down. So let me grab another longer piece of solder. And go back to fast motion, and I will be listening to, let's see, Schubert's Fantasy in F minor. Okay, everything's soldered down, and as you may have noticed, you probably didn't, but again, I globbed the solder onto the jacks because they're carrying a lot of mechanical responsibility for keeping this all together. Now, he does say you should trim off the legs from the jacks because they might interfere when you mate the boards. Actually, he doesn't. He says the push button and the MIDI connector. Push button legs aren't sticking out very far at all, and I haven't put the MIDI connector on. I forgot to do that. So drop the MIDI connector through the center. And once again, I know I keep saying it, but it's really critical, particularly on this, the jacks and the MIDI connector. Don't skimp on the solder, because you're going to be pulling the MIDI cable in and out of this connector 100 times a month, maybe, or a year, I don't know. Depends on how you work. Okay, now we're going to mate the two boards. And we want to make sure that the screw holes line up too. I think we're all good. Nope, now I just jumped out of that one. Okay, we're all clipped together. Are we completely flat on them? Seems to be. And our screw hole lines up. So there it is. Only one minor thing left to do. Plug the power cable in. And I didn't trim the legs on the MIDI connector because they weren't long enough to interfere, and I can see right now I didn't think they'd be long enough to interfere, and they don't interfere. So it's all together. We only have one thing left, and that's a black panel nut. Maybe that was the one. I don't know what that's for. Maybe that was to replace the standard nut on the switch. I don't know. And now it's all ready to go. But I'm not. It's late. The cats are probably wondering why I haven't come in to give them food yet. So that'll be it for this session. We'll power it on next time. Okay, so now we're ready to rock and roll with this unit. As you can see, I've got it installed in my Eurorck workshop test rig, which I built today. I didn't have one, so I figured I'd build one. And we are going to be using it with Logic Pro. As you can see, it's sending MIDI signals out right now. And theoretically, we'll hear it through that custom amp I built a couple of months ago on the floor. Because the MIDI thing I'm going to be feeding into this Duskwork oscillator that I put together like earlier this week. I haven't posted that video yet, but you'll see it. And I have not turned on any of this yet. So we're going to power up right now. And first, the Duskwork I've powered up, so I know that that works. The MIDI thing, who knows? We may get magic smoke coming out of it. So the power is coming on now, and this power supply takes a couple of seconds. Oop. So the Duskworks came up immediately, and I'm not seeing anything out of the MIDI thing. I'm not even seeing a pilot light. Oh, no, it's getting it there. So there's no pilot light for that, which is actually interesting. The mode switch, you hold it down, and then you can select various modes, and the manual that goes with, the user manual that goes with this unit is very good. And I'm going to bring it up now. I should already have it up, but I didn't. There are a bunch of things you can set with this. The user's manual is very rich. The CV outputs are there. The gate outputs are there, of course. Then we've got clock out and start stop. Now the mode button, which is here, has two things. It has learn and mode. So mode selects what it does. For example, and this is interesting, you tell it what mode to do. You use your keyboard to tell it what to do. So if I hold down this for 5 seconds until the mode LED is lit, now when I send MIDI signals into it, it tells what mode to go into. So if I send it a C note MIDI, it sets it in monophonic, C sharp sets it in dual, D sets it to quad, D sharp is multi-trigger, and so on. So it uses the MIDI input signals of the note values to configure what mode it's going to be in. And in this case, what we're doing right now, I don't really care what it does except simply pass on some CV. So we single click gets us out of that. Now learn is, and there's a bunch of other things you can do. You can send on other MIDI channels. If you broadcast on MIDI channel 2 on mode, now you can change system options from retrigger mode to clock resolution, and then you can also calibrate. And what that means is you're telling the MIDI thing, here's the lowest note that I'm going to be sending you, and here's the highest if you want. Lowest is what's really important. So again, even though there's only one button, using an actual musical keyboard allows you to do a lot of configuration very easily, and it's a very cute thing. I mean, not cute. It's a very interesting thing. So I'm going to plug the MIDI cable that's coming out of my MacBook Pro with Logic, going into a crappy, oh, I'm sorry, did I say that? going into a Behringer USB audio interface. So theoretically, when I plug this in, we should start seeing some LED action from MIDI ons and MIDI off. Okay, so learn, if you can see, is flashing, indicating that there's some MIDI activity. So as we can see, I'm triggering on quarter notes, and it's going beep, beep, beep. So that's good. That's started. We know basically that MIDI input going in to the MIDI thing is actually working. Now I'm going to go from CV1 out into CV on this Duskwork oscillator. I don't like the jacks he used. This oscillator has a triangle wave, a saw wave, and a square wave. So I'm going to bring up the amplifier a little bit so you can hear it. So as you can hear, it does actually work. So the MIDI thing is doing exactly what we wanted, which is taking a MIDI signal, converting it to CV, and telling this oscillator, take your bass note and modify it by, oop, that's a little loud. I'm going to adjust some volumes here. We'll bring the triangle wave up. So basically that's it. The MIDI thing does exactly what it's supposed to do. There are a huge amount of things you can do to set options for clock resolution, start-stop behavior, calibration, retrigger. There's drum machine mode. There's all kinds of good stuff in this. All in all, I believe this MIDI thing, MIDI to CV and to gate, is a really good unit. I would highly recommend it. So thanks for watching, and I'll be looking forward to seeing you in the next video.